Ah, yes. Okay. PVS, can we
Yes,
finish?
sir. We'll start now, sir. Good evening, participants. On behalf of CSI Chennai, ACM Chennai, IEEE CS Madras chapters, we cordially invite you to a webinar on design patterns. A quick introduction by Dr. Venkat Subramaniam, award-winning author, founder of Agile Developing, and adjunct faculty at the University of Houston, USA. We always know properly designed systems result in savings of resources such as time and effort during the project implementation phase. So it is very, very important to know what are all the design patterns, how to go about it. This presentation will talk about what are all the design patterns, why are we drawn towards them, what are some of the challenges in using patterns. In this presentation, Dr. Venkat will start with a short discussion on the purpose of design patterns and the way patterns are classified. He will then, using live code examples, dive into some popular design patterns. He will conclude with a discussion on the relationships between programming languages and design patterns and the challenges of identifying and using them. Dr. Venkat Subramaniam is an award-winning author, founder of Agile Developing, creator of AgileLearner.com, co-founder of the Dev.Next software conference, and an instructional professor at the University of Houston. He has trained and mentored thousands of software developers in the US, Canada, Europe, and Asia, and is regularly invited speaker at several international conferences. Dr. Venkat helps his clients effectively apply and succeed with sustainable agile practices on their software projects. Dr. Venkat is a co-author of the multiple technical books, including the 2007 Jolt Productivity Award-winning book, that is Practices of an Agile Developer. Over to Dr. Venkat Subramaniam. Thank you.
Thank you very much. Really appreciate it. Thanks, everyone, for joining. I want to thank the organizers for the efforts to get this together. Before we get started, a few things to quickly note. We're going to go for about 90 minutes, so just be aware of it. And also, the best time to ask questions or make comments is anytime you have a question or a comment, it's most welcome. You don't have to wait till the end to ask questions. Please post the questions on the chat. I'll be more than happy to respond to them right away. So with that said, let's get started. Well, before we talk about design patterns, I want to start with the word of caution about design patterns. You know, we can say that grandma makes the best pie, right? Well, we all have talked about the food that grandma makes, and we've been telling everybody how wonderful this food is, how tasty it is. Well, some of your friends get together and they tell you, well, if grandma's food is so good, why don't you make it? And so you couldn't really resist that. You couldn't say no. So one Saturday, you invite all your friends to come home. And that morning, you get started very early and you want to make this dish. So a week before that, you call grandma on the phone and say, Grandma, my friends are coming home. I've been telling about how wonderful your food is. And they said, I have to make it. So please, can you give me the recipes? And grandma says, oh, it's really easy. Take some flour, take some sugar. And you're like, whoa, wait a minute. How much do I take? And grandma says, take 2. It's like teaspoon or tablespoon. And you write down all the notes about the recipe. And then you ask grandma, what are the best practices? What are the do's and don'ts? And after writing all this down, on that Saturday, you get started early in the morning and you make that dish. How did that turn out to be? Well, the last time I tried, it was a disaster. I lost the spoon and the vessel with the dish. And then you go to grandma the next week and you tell grandma, this was a disaster. You did not give me the right recipe. And grandma says, what went wrong? What could possibly go wrong? It's really easy to do. And then grandma says, why don't we just go make it while we talk? And you say, that's a great idea. And so you walk into the kitchen and you see grandma make the food. And how does grandma make the dish? She takes 2 teaspoons of sugar, measures very accurately, and puts it, right? No. She's having a good time talking to you, and she takes some sugar and throws it in like that. And you said, whoa, what was that? And she says, it was sugar. And you said, how much did you put? And she says, enough. And that's when you realize grandma doesn't use the recipe that she gave you. And grandma is so skilled, she does things really naturally. Where am I getting with this story? Well, what I'm trying to say here is that about 25 years ago, there was an absolutely phenomenal book that was written. And that book was called Design Patterns, the Elements of Reusable Software Development. And this book was written by 4 people in the industry. I call them the grandparents of the industry. And those 4 people were brilliant in what they did. They had a lot of experience developing software. And the worst thing they ever did as a group of 4, or a gang of 4 as they're called, is to write the damn book. And the problem is, everybody who read that book suddenly said, oh, I could do this. And then the result is the grandma's recipe. It's a disaster in the industry. Now that I encouraged you so much about design patterns, let's talk about what design patterns are. Well, jokes aside, one thing I want to emphasize is we cannot really get good at design pattern only by reading a book or only by listening to somebody. Sure, those things are important, but really getting good at design patterns comes from writing really bad code and have them reviewed by somebody with experience, and go back and rewrite the code and then get it reviewed again. And over time, we get really good at using design patterns. But then why should we really use design patterns? Well, there are 2 different reasons why design patterns are really useful. These are helpful to come up with solutions that are being tried out so often that we don't have to reinvent the wheel. We can simply use what's been tried and tested and well known already. So we can gain from the collective knowledge and the collective wisdom of people who have developed software before us and around us. That's one of the biggest benefits of using design patterns, is that we gain from the collective wisdom and the collective knowledge of people who have already used them. But how do you really find these design patterns? Well, these have been cataloged quite effectively. There's a lot of resources that show these patterns and how we can use them. However, it also, like I said earlier, we find them with experience. We find them by probing. In other words, rather than trying to sit down and say, what pattern do I want to use? In fact, I would encourage you to think about it this way. Suppose you wake up in the morning and the very first thing in your mind when you get out of the bed is, what design pattern I'm going to use today? I recommend you call the boss and say you're very sick and you're not coming to work today, because that's not the way you want to apply design patterns. You want design patterns to emerge out of the problem and you want to really fit into it. So in a way, if you really think about design patterns, think of a diagramming application like a fig application where you have these grids and you are trying to place a rectangle on the grid. And as you're trying to place the rectangle on the grid, you might have a square on the grid, and the rectangle may just attach to one of the corners of the grid. And that is exactly how I see design patterns. You take a problem, you're trying to find a solution, and you gravitate towards a particular solution, and you may say, oh, this pattern looks really interesting. Maybe I should use it right now. So you gravitate towards a pattern rather than sitting and picking patterns arbitrarily. So let's talk a little bit about what are really patterns in that case. Well, design patterns are really common set of solutions that have been used over and over and over by a lot of developers, tens of thousands of developers over time. Now, it's important to keep in mind that design patterns are not code. Design patterns are not libraries. If it's a code, you can copy and paste the code. If it's a library, you can use that library. Design pattern is not code. Design pattern is not library. So you cannot download a design pattern or copy and paste a design pattern and integrate with it and use it. So design pattern is a solution. In a way, if you really think about it, Imagine you're having, some kind of a difficulty in your life, in your work, in your situation. What do we do normally, right? We call our uncles and aunts, normally not our parents, right? We call our uncle and aunt because uncle and aunt are close enough to us, but also distant enough from us. So they're very objective in giving those opinions to us. And so we call an uncle or an aunt and say, hey, I'm having this problem at work. What do you think we should do? And they may think about this and say, have you tried this? Have you tried this? And they give you some suggestions. And then you say, wow, that was really helpful. Thank you. And then what do? You go back and try those solutions. That's exactly what a design pattern really is. So they didn't give you a code to download. They didn't walk with you to work. They didn't do the work for you. They just gave you a suggestion as to how you could solve it. And you solved your problem using their suggestion. They may tell you, oh, when you go to the boss, when you go to the assistant, when you go to the secretary, well, these are different things they provide for you. On the other hand, you go back and implement in your own situation. One question here is, do you mean to say design patterns are something like a flow chart? Well, they don't have to be a flow chart because a flow chart often is procedural. So a flow chart often is a sequence of steps you may take to solve a particular problem. But a design pattern may not be a sequence of steps to take to solve a problem. A design pattern may be an approach, a structure, a way to interact, and so on. So it may be a little bit broader than flowchart, but that's a really good starting point to think about it. Like, for example, you could take a flowchart and you can implement it in different languages and different frameworks. So it's not too far from that, but it's not restricted to being a flowchart either. So that's a really good question. So essentially, it's an idea, it's a concept, it's a way of thinking that you want to apply in a given situation, mainly because that way of thinking is something that is really has been helpful. It's not necessarily a strategy in the sense of the word strategy. Design patterns are actually pretty tactical because they may tell you how to solve a particular problem rather than a strategy in general. I want to kind of quickly emphasize this question about strategy. There is a pattern called a strategy pattern. We're not talking about that right now. We're talking about the English word strategy versus tactics. Well, design patterns often are not really strategies. They're more tactical in that sense. Design patterns focus on a very narrow problem to solve rather than being a strategy on an overall approach, how we could take on a broader scale. So design pattern scope is fairly limited, and that's not a bad thing. That's actually a good thing because they're very targeted to solve a particular problem. So with that said, what kind of design patterns would we want to use? Well, design patterns fall into different categories. Now, these patterns really are not limited. There are more patterns, categories than this. There's also architectural patterns compared to design patterns. Architectural patterns deal with architecture of systems. Design patterns deal with design of subsystems or components or classes. So you can think of design pattern to be here, and you can think of architectural pattern to be up here. An architectural pattern may give you that strategy that Nandini is referring to here. So your architectural patterns may be more strategic. Design patterns are more tactical at a low level, code level, if you will. So in terms of categories of patterns, one category is called creational patterns. So creational pattern really focuses on, as the word alludes to, how we create objects. You might have a situation where you might have to choose between multiple different objects you want to create. Let me give you a really silly example. I don't drink soft drinks these days. When I was young, I used to. Now that I'm a lot older, I care a lot more about my health. So I'm not promoting any soft drink when I say this, but let's assume that I drink soft drink. Now I may go to a restaurant and I may ask them, can I have Pepsi, please? And they may give me a stare and say, we don't give Pepsis here. Would you like Coke? I'm like, fine, Coke is fine. Give it to me. I may go to another restaurant. I may say, can I have Coke, please? And they may say, we don't serve Coke here. Is Pepsi okay? I'm like, okay, fine, give me Pepsi. Or I can simply go to the restaurant and say, may I have a soft drink, please? And they may say, is Coke okay? I'm like, that's fine. I may go to another restaurant and say, may I have a soft drink, please? And they may say, is Pepsi okay? That's fine. So you can think of the restaurant, so to say, as a soft drink factory. But one restaurant may give me Coke, another restaurant may give me Pepsi, a third restaurant may give me some other soft drink. But the point is, me as a client, a consumer, have abstracted myself. That's the key word right there, abstracting yourself. So I'm abstracting myself from the details of Coke versus Pepsi versus Mountain Dew. And instead, I'm going to simply say, may I have a soft drink, please? And the factory would give me the appropriate soft drink, the restaurant in this case, a Pepsi or a Coke. That is creational pattern. So a creational pattern abstracts the client or the consumer of an interface with the implementations of that interface. The soft drink is the interface. The implementation is Coke, Pepsi, and so on. So that's basically what a creational pattern is focused upon. The abstraction of the object that you use to the object that you really end up using. On the other hand, structural patterns focus really on how objects are structured or organized and how they are laid out. How do objects, work with each other? That is basically a structural pattern. So the concern here is not about creating the object. The concern is how we organize the object so we can work with these objects together. And in terms of structural pattern, you might say, here is a particular object and here is another object. And I want to, relate them to inheritance or delegation so they can work together to solve my problem. That's your structural pattern. So as an example, in this case, you might say that I would like to really use a particular object, but that object itself may be a collection of other objects. And this happens a lot in what we do. For example, I might have a little, a tray where I may have a drink on it, I may have a little pastry on it, but I may have a collection of these items on a tray, but I could have different types of trays depending on what I really want. How do I structure these so that I can really ask for different types of food, but yet be able to treat them commonly? So that's basically what a structural pattern really comes in. A third category is a behavioral pattern. Let me put a word that makes it really easy to understand what a behavioral pattern really is. And the word is algorithm. So essentially, in the case of a behavioral pattern, you're focused on your algorithm, or how do you, really perform a certain operation or conduct a particular algorithm. So this is really down to a procedure. How do I really implement this procedure in a way that I can really get a better extensibility of the software? That's where a behavioral pattern really comes in. Now, when we talk about the categories of patterns, what makes one thing really challenging? Okay, there are two things that make it really challenging. The first is, remember, I mentioned that design patterns are not downloadable. You don't just download them and use them in your code. So if you take a piece of code, it is not unusual for multiple patterns to come together and intertwine in your solution. So in other words, if I show you a bit of code, that particular code may potentially have 1, 2, 3, or 4 different patterns intertwined. And you kind of have to have a vision to kind of adjust your lenses and see this part is one pattern, that part is another pattern, this part is a different pattern. You must be able to discern between these patterns when you look at these patterns. So in other words, when it comes to patterns, patterns often intertwine and work with each other. This is a good thing and a bad thing in the same tone. It's a good thing because multiple patterns come together to solve a problem. It's a bad thing because it becomes a little hard for us in the beginning to be able to say what pattern we are using, and we should be able to sift through and say, here we use this pattern, but we mix this pattern here. Sometimes we mix the pattern to solve a problem. Sometimes we use one pattern within the solution of another pattern as well, and that can make things a little bit more complex. when it comes to the scope of the patterns, what kind of approach do you really use to solve your problem using that particular pattern? So if you're using inheritance as a predominant approach, that particular approach or way of solving your problem, they have a name called a class-based scope. So essentially a class-based scope is where you are using inheritance as the primary tool to solve your problem. On the other hand, if you use delegation as a primary tool to solve your problem, this is called object-based. Now, why this is really interesting is this is, fairly limiting and restrictive, and only a few do this. On the other hand, when it comes to an object-based, this one, on the other hand, is a very flexible, and most patterns fall into this particular category. So it's kind of interesting how, when you look at the patterns, what problem do they solve is that, right? So what is the concern here? In the case of a scope, the concern is how. How do you really solve your problem compared to what problem are you really trying to solve? So categories are the what's, the scopes are the how. What kind of tool or technique do you use to solve your problem? That is basically class-based versus object-based. And it turns out inheritance is the worst of all the 4 features in object-oriented programming. Encapsulation, abstraction, inheritance, and polymorphism. Abstraction is extremely important. We conceptualize ideas. The encapsulation is really important because we do information hiding, and that results in better, extensibility of code. Polymorphism is extremely important because that's what really makes the code truly extensible, combined with encapsulation. Inheritance is the weakest link of all of this. And inheritance is very limiting in a lot of languages, and that's why it's not that flexible, and not too many patterns use it, thankfully. Delegation is extremely powerful, and a lot of patterns end up actually using it. Well, enough of that talking. Now let's jump in and take a look at some of these patterns that we could potentially use in our common everyday task. I'm going to talk about a few different creational patterns. So the first pattern I want to talk about is an abstract factory pattern. Then I'll talk about factory method. But then I will talk about how do you know which one you are using really, and show the difference between them. So what is really an abstract factory? Well, imagine for a minute that you are working in a computer shop, let's say. So a computer manufacturer, let's say, and so computer manufacturer is going to be interested in manufacturing different kinds of computers. They're all the same computer manufacturer, but they make different models of these computers. So one particular model A may have one type of memory. A model B may have another type of memory. One model may have one type of CPU. Another model may have another type of CPU, and you want to be able to manufacture these models of so these basically all these different models you are creating, essentially you want those models to be easily used by users, but you want to be able to create different models based on what you're trying to do. So here's a way to think about it. So let's create an interface. I'm using Java as an example here, but you could do this in almost any language. So an interface called a computer, or you can create an abstract class if you want to. That is perfectly fine as well. So you can say an abstract class called a computer or an interface. It's entirely up to you. But what does this particular interface or abstract class computer really have? So for the sake of this discussion, I'm going to simply use an interface, but you can change it to an abstract class. So what does this class interface called computer really have? Well, it is going to have a memory, and we will call this as, create memory, if you will. So the create memory is going to return a memory to you. Similarly, it may have a CPU. We'll call this a create CPU. CPU, and I'm going to call this one here as a computer factory, if you will. So in this case, the computer factory, as you can see, is going to have a create memory, but it also has a create CPU, if you will. And similarly, you can have more things that come in later on. We can kind of extend this idea further. So this computer factory says, I'm going to create a memory, I'm going to create a CPU. Now, when it comes to abstract factory, I want you to think about this word family. So the word family makes a really good sense. A family of products, exist, and a client wants to use various products from one family or another. So in other words, you want to be able to switch between these families of products. So how would this really work in that case? So you may have a client in this case equal to new client, and the client may say something along the lines of, for example, the client may say, computer factory, let's call it factory equal to new. And we don't know what we're going to use here yet. We'll come back to that. So they may say memory is equal to, so this is the client itself that we are in. So I may say memory is equal to, and I may say factory dot create memory, right? So we could use that. Similarly, I may say CPU, and CPU is equal to factory dot create CPU, if you will, and then so on. They may use that. But notice this code doesn't really know about which memory or which CPU they're going to really use. Then what we're going to do is to create a class called computer factory A, which then implements, if you will, the computer factory. And here it says memory, create memory is going to simply say return new memory A, because it's the family of A type, if you will. On the other hand, it may say CPU, if you will, and create CPU, and this is going to say return new CPU, let's say A, and return it. Likewise, what we may actually do is simply say this is a factory B, but this is going to really return a B memory, and this is going to be a CPU B. But guess what? You might even have, it's entirely up to you, right? You may have a factory C, which may decide to return a memory A, if you will, and a CPU B. So this could be a different combination that you want to put together in how you create your objects. That's perfectly fine. But the point really is you get this family of products given to you. So then if you go back to this code, notice this could say new computer factory A, then the rest of the code doesn't have to change because that factory tells you what you want to really use. But let's go a little further with this. Let's go ahead and call this one as a create computer. And this is going to take a computer factory, and we'll call it as a factory right there, and remove the first line. Now just see what happened. Now we can go back here and say in this case, let's say this is the main function, and we can say in this case, this is going to return a computer, let's say in the very end of this whole thing. Then we can simply say computer, we can call this as computer 1. So computer 1 is equal to create computer, but notice what I'm going to say, new computer factory AA, and I can call this function like so. Similarly, I can call this again with a computer 2 or a computer 3, but this could be a B, if you will, and this could be a C. So the idea behind this is you are completely abstracted out what families of products come together. Now, what is the benefit we got out of this approach? The benefit we got out of this approach is, look at the code here that I've highlighted from line 29 all the way down. That code doesn't have to change at all if you decide to introduce a new computer, if you will. So the new computer potentially may have a completely different memory, a completely different CPU, and so on. And as a result, those have been abstracted by the factory. So let's see what the benefit is. The benefit is the code that is down below becomes highly extensible. You can introduce new combination of products, but you don't have to change the way rest of your application actually works. And that is huge from the benefit of extensibility of software systems, because the worst software is where you have to change everything all the time. And that becomes an economic drawback when it comes to developing software. The benefit of this approach is you have isolated part that changes and majority of the system doesn't have to change for that reason. So let's talk something about the pros and cons as well. What are the good news and what are the bad news? So what are the pros? The pros is that first of all, the benefit is more extensible, right? Because we abstracted in a sense, we abstracted the family of products really, and we abstracted the family of products from the users of the products. So this is one of the biggest benefit you get is we did this abstraction of these products. And more benefit is families of products, we could say new families of products, families of products can be easily introduced, right? Can be introduced with really, right, with no change to existing code. And if at all there's a change, it's extremely minimum change. But what are some of the drawbacks? What are the cons of this approach? Well, the families can't really have a different product. So families can't really have a new item in their product. For example, in our example, you have a memory, you have a CPU, you have a keyboard, let's say, and you have, let's say, a mouse. This is all great. Now, tomorrow, you decide to introduce a new part which is not already in these families. Whatever that part may be, right? You decide to introduce a little pen that you want to add, right? So you're going to introduce a pen that people can use with this product. Sorry, you cannot do that. Why? Because the pen is not part of your family already. Notice that this doesn't have a create pen. So you cannot suddenly introduce a create pen because all the families have to consistently offer the same items. They can offer variations of the items. One family can have one type of memory, another family can have another type of memory. But all of a sudden, one family cannot say, hey, we offer pen too. Sorry, that's not possible. So there are some limitations to this approach in terms of what Abstract Factory can do as well. And so as a result, there are some pros and cons with this approach too that you have to be very careful about when it comes to using this. So with that said, that is basically, how do you know it's an abstract factory? I'll give you a clue about how to know it's an abstract factory. You have a client that you have, and the client is going to, the client or the user is going to talk to a factory, and often this is called the abstract factory. And the abstract factory, you're going to talk to it, and the abstract factory is going to have a factory one, if you will. So factory 1, factory 2, and factory 3, all of these and more, if you will, are really classes that inherit from that particular interface or abstract class. So all this, I'm using my artistic skill here. You can see this is the inheritance that I'm going to bring in here. So this is going to be all these classes, as you would expect. I'm going to put a little horizontal line here for inheritance. And all these classes are going to inherit from that particular class, if you will. So that's basically the idea behind this, is that that's inheritance that you're seeing right there. So all this inheritance is going to make that happen. So essentially in the abstract factory, a client talks to a factory, which is an abstraction or an interface, and you have these factory 1, factory 2, factory 3, or implementations. Now, what I don't show below here is that the factory one now talks to a similar hierarchy of memory over here, and a CPU here, and a keyboard here, and so on. And what do you have in here? This is going to talk to memory one, a CPU one, and a keyboard one, and so on. Similarly, this is going to talk to memory 2, CPU 2, and keyboard 2, and so on. You get the idea, right? So these are the specifics where memory 1 inherits from memory, CPU 1 inherits from CPU, and keyboard 1 inherits from keyboard. And similarly, factory 3 may decide to say, hey, I'm going to use memory 1, but I'm going to use CPU 1, but I'm going to use keyboard 3. That could be a different family, if you will, and you can have all these combination of families that you create. So hopefully that gives you an idea about how abstract factories can help us to depend on a piece of code, but that code can be abstracted out so we can have different implementations that come through later on. You know, if I was in a regular teaching session, I would literally spend 2 hours just on abstract factory, where I'll be writing this code and we'll be running it and demoing it. But obviously we won't be able to do that today. But you can take that further, right? What are you going to do tonight after all? So you can write that code and you can run it and play with it and see how you can actually implement, and you'll get an idea of actually using the abstract factory. So that's basically the idea of what an abstract factory is. Now, here's really confusing. We see abstract factory, but then we see factory method. But I'm going to talk about how we know the difference between them. So what is the factory method? Well, I want to, first of all, tear this apart a little bit. I want you to look at the word factory and the word method. I think we know what the word factory is right now. So what is factory? A factory abstracts the creation of an object from the object, the one that wants to use the object. So the client of the user of the object doesn't know actually what object you're creating on the other side. That's basically what a factory gives you. But then what in the world is the word method? Now, here's a way to really think about it. The word method, as we know, is, what is a method? A method is an instance, right? Instance function of a class. Aha, now we know what this means. Factory method is where an instance function of a function of a class acts as a factory. So that's basically what a factory method is, right? Once you tear up the words, it becomes really easy to understand. A method is an instance function of a class. We know this in languages like Java and C#. And so a factory method is where the factory is an instance function of a class that acts as a factory. Now let's understand what this really means and why this is called the factory method. Now imagine that a company has travelers. Now, who is a traveler? Anybody in the company may travel. I may be a programmer in a company and I travel. I may be a salesperson in a company, I may travel. I may be an executive in a company, I may travel. So when I travel, what are the things I really need? So I'm going to say class employee, and the employee has a function called, get ready for travel. So the get ready for travel, what am I going to go do to get ready for travel? Hey, the first thing I'm going to do is hotel, I'm going to say is equal to book hotel. The first thing I need to do is to book a hotel if I want to travel, isn't it? Because if I don't have a hotel to stay, where am I going to be when I travel? So I need to book a hotel. Okay, great. Then I'm going to say car equal to a reserved car, because I got to reserve a car if I want to be, going to the place where I need to go. And then what I'm going to do is, more things I want to do. So an employee is going to have a get ready for travel with a book hotel and book and so on. But I'm going to make this as an abstract employee. Now, if you really think about it, right? Every company has employees, but can you ever put a finger on somebody and say, that person is just an employee, doesn't have any other designation? No. We all are employees, but nobody is only an employee. We are a programmer, we are an assistant, we are an executive, we are a program manager, we are a tester, whatever that is. But all of us are employees. Now, what kind of hotel can I book? Well, sorry, that depends on what position you have in the company. If you are an executive, you might stay in a 5-star hotel because you want to entertain, people from other companies. If you're like me, where I'm a programmer, I get to stay in the cheapest hotel, right? Because the company gives me a budget and says, that's how much I'm going to give you, Venkat. You're not going to stay anywhere else. Similarly, what kind of car do I want to rent? Well, if I'm an executive in a company, I get to rent a fancy car. If I'm a salesperson in a company, I get to rent a fancy car because I got to take my clients around for golfing. But if I'm a programmer in a company, I drive a not so fancy car. But how do you abstract all these details in your application? So notice what I'm going to do. I am going to say in here, if you really want to throw the word public, you can. But what I'm going to do here is I'm going to say protected and hotel, and I'm going to say book hotel. But this is an abstract function, as you can see right there. So it's an abstract function called book hotel. Similarly, an abstract function called a reserve car, if you will. So notice what happened here just all of a sudden. The employee is abstracting the get ready for travel, but the employee says, I cannot decide what kind of hotel to book or the car to book or various other things, but I'm going to let my derived classes really decide that for me. So as a result, I have a class called programmer, which extends, of course, from employee. And what does a programmer do? The programmer then says, I am going to have the implementation of these methods, wherein I'm going to say the book hotel, these are no longer abstract in the programmer, and I'm going to simply say, what do I do? Return. And what am I going to return in each of these things? This might be, a 3-star, right? Star hotel. A programmer, lowly programmer like me gets a 3-star hotel. And what about a car? Normal, a regular car, right? So regular car, nothing really, fancy. On the other hand, you have a salesperson, and what does the salesperson do? A salesperson, on the other hand, those are the people with a lot of money, right? And that person says, I'm going to reserve a 5-star hotel, and I'm going to get really a fancy car, maybe a convertible, right? So the point really is, now let's understand how this actually worked. I can go back to the code and say, employee. And so, let's get back for a second. I'm going to go back here and say public, let's say static void, prepare, let's just call it as prepare. And this is employee, and I'll just simply send an employee right in here. Now, before we get to that method, I might say prepare a new salesperson, if you will, a salesperson, or I might even say over here, prepare, and this could be a new programmer or a manager and so on. But then what am I going to do in here? I'm going to simply say employee dot get ready for travel. But look at the beauty of this. If you go to the employee and say, what kind of car do you have? And the employee says, I've got a fancy car. If the employee were a salesperson, or says, I have a regular car if it's a programmer. If you go to the employee and ask, what kind of hotel do you have? They tell you they have a 5-star hotel or a 3-star hotel, depending on the type of employee they were. So if you look at the solution, what did we do? Notice one more time, we abstracted the creation of these objects to a different place. So this is new and new. But those are isolated from the employee, which is simply saying, I don't care about the specific ones you create. If you want to go to a travel, here are the things you need. I'm going to prepare them. Now, how does this really look? the way this looks is you have a factory, but the factory has abstract methods in this case. And then you have a derived class 1, which will override the factory method. And similarly, you're going to have a derived class 2, if you will, and that's going to also override the factory methods. I should put a plural here, methods, right? So an abstract methods and then a client method, if you will, uses the abstract methods. So this is really the factory method pattern in a nutshell. So essentially what you're saying is, I've got this employee at the top, which has a function called get prepared for travel, but it depends on its abstract methods. But those methods are implemented by the derived classes to provide variations. So if I introduce a new employee, I don't have to change the code up here because the new employee conforms to that expectation, but the new employee position can say what kind of hotel they get, what kind of car they get, and so on. So that's basically what a factory method really provides for us. So a factory method, how do you tell the difference between those two? Well, the way to tell the difference is, notice in the case of a factory method, you have a bunch of abstract methods and the derived classes actually implement it. So what is the primary solution we use in here? In the case of abstract factory, if you will, in the case of abstract factory, you have a client that talks to a factory like that. So what is the primary tool we use in this case? That is delegation. So that becomes an object scope, if you will. On the other hand, if you look at the factory method, how does that work? The way this works is that client is using inheritance. So derived class, has the method, if you will. So the derived class, has a method that overrides, if you will. So in this case, override abstract factory method, where the method is sitting here as an abstract method, as you know. So this is the abstract method that is sitting right in there at the very top. So as a result, if you notice, what is the primary solution we are using here? Notice the word derived class. So the predominant solution here is inheritance. So as a result, it's a class scope if you really think about it. So one question here is, does this mean that the factory method supports the service-oriented architecture? No, it doesn't at all. The reason is, this is very tactical compared to service-oriented architecture, which is so broad and on the top level. Architectural patterns may not use any design patterns at all, or may use completely different design patterns. So there's no relationship at all between those two. They are completely independent. The architectural patterns like service-oriented architecture is so top-level strategic, whereas the design patterns like factory method are so tactical. You are dealing with a bunch of classes. You might use a factory method in a situation where you have no service-oriented architecture at all. You could use that in microservices. You could use in monoliths. You could use in so many architectures. Similarly, a service-oriented architecture may or may not use any of these patterns. So there's no relationship at all between those two in terms of where it fits in, because they're completely in different domains, so to use the word. So essentially, in the case of factory method, the factory method relies on derived classes. So it's a class-based scope. On the other hand, abstract factory depends on another object to provide the service. It's a delegation approach. It's an object scope. And you may argue, hey, wait a minute, you may say, does it not appear that we are using factory method within abstract factory, right? So that's a really good observation if you were able to derive that conclusion. So if you really think about it, it appears that we are using the factory method within abstract factory. How so? The client is here, it talks to the abstract class here, but the derived factories decide what object to create. So this is abstract factory, but this is factory method. So factory method can be used without abstract factory, but abstract factory often is used with the factory method. This is where it gets a little tricky, right? Because patterns may be used with other patterns too in their solutions, and that's not unlikely. So that's basically about the abstract factory and factory method. I'll mention Singleton only for a few minutes here because it's a very common pattern. So what is a Singleton pattern? So here is my definition of Singleton pattern. It is a pattern we take 5 minutes to understand and a lifetime to get it correctly implemented. This is what I love about Singleton pattern. Singleton pattern is a very tricky pattern to implement. It only takes 5 minutes to understand the pattern. It almost takes a lifetime to get it correctly implemented. So what is Singleton pattern? A Singleton pattern simply says the following. If you think of an abstract class in most languages, including Java and C#, can have 0 direct instances, right? So you cannot have any instances of that class directly. A normal class, including a final class, may have 0, 1, or any number, if you will, number of instances. But what if you want to limit a class to have 1 or a limited set of number of instances? So it's not 1. 1 is a special case. You may say 3, you may say 5, whatever that could be. So, but why would you want to do this? Think of a database manager, if you will. How many database managers do you need in an application? 1. So what if you want a logger? How many loggers do you want? 1. So a lot of these objects, you want only 1 of them in your application. So a singleton, a singleton is a way to limit the number of objects to 1 or a handful. So, there are times when you may say 3, 4, 5, and you may say just do a handful. So you say, gosh, that should be really easy, isn't it? Well, that's where the trouble starts. So how do you limit the number of instances to just 1? I'll tell you the reasons why this is so hard. The first thing you may say is, well, no problem. I'm going to limit them to 1 by simply making the constructor private, put a static field, and provide a static method. When you call the static method, I'll initialize the field and return the object. If the field already exists, I'll just return it. Hey, great idea. And then if 3 weeks goes by, you see a kid playing with 2 objects of your singleton. And you're like, kid, how did you create 2 objects? And the kid is like, oh, I used multi-threading. And when I used multi-threading, I created 2 threads. And from both the threads, I called the get method at the same time. And your get method came through 2 threads. They both checked the field. It was a static field, which was empty. So they both created an object and they returned it to me. And look, I have 2 objects. I'm like, darn it, kid, you're too smart for me. I'm going to go fix it. And you go put a lock in the code. And then you say, I'm done. So now you cannot create multiple threads. Aha. And 3 weeks goes by. It's not the kid, but the cousin of the kid. And what is she doing? She's playing with 2 objects of your singleton. And you're like, darn it, kid, how did you do that? And the kid is like, well, I serialized your object and I deserialized this. You're like, darn it. Now you created objects using serialization. I'm going to plug that hole. Now, this is a path to destruction because every time you plug the hole, somebody creates a new hole to play with. This is why singleton is so darn difficult because you got to take care of multi-threading, you got to take care of serialization, you got to take care of all of this. And when you're done, you are error-proofing your code and not getting your work done. So this is so bad that the best solution is please don't do it. So if I really want a singleton, what should I do? Well, in Java, enums are good solution for Singleton. I know that sounds really weird, but we use enums because the compiler takes care of that for us. We don't have to worry about it. In languages like Scala and Kotlin, singletons are implemented in the language already. So you can just do object keyword and get a singleton. So the moral of the story is singleton is, this is my experience, which is consistent with the industry, is that it's a pattern that takes 5 minutes to understand. We just spend 5 minutes on it, but it takes a lifetime to get it right. So in Java, use enum. In languages like Kotlin and Scala, use the built-in feature rather than doing it yourself. And that is something I would highly encourage. So that's all I'm going to talk about creational patterns, but hopefully that gives you an idea about why we want to use creational patterns. I'm going to just pause for about 10 seconds to 15 seconds to see if there are any questions or comments before we move to the next topic over here. So thoughts, questions, comments, feedback also. Is the pace too fast? Or the pace is too the pace is too slow? This is boring. I would rather paint my toenails than listen to you, Venkat. Or this is too exciting. I cannot stop listening. Whatever it is. So participate. Throw your comments in the chat line. Tell me how things are going. Tell me your thoughts. Tell me you're connected. And what are your thoughts? I'll just give about 10, 15 seconds. So please continue. All right, wonderful. Thanks for that feedback, Rupesh. Cool, keep going. Awesome, thank you. Any thoughts, any questions? None so far? Okay. Well, keep your questions coming along the way, so don't hesitate. So awesome. So let's keep going. And if you have any questions or thoughts, absolutely post them on the chat and we'll talk about it. Well, the next thing I want to talk about here is the structural patterns. Structural patterns are useful to really how we structure or position objects to work with each other. And there are several patterns in this area, but I'll just mention a couple of them. One of them is an adapter pattern. Now, adapter pattern is so common in what we do. We've used this so much, isn't it? You know, I travel internationally. Oh, question here. Can the common object type could be selected for all type of illustrations to get comparative idea? No, we cannot. And the reason really is the patterns all don't solve the same problem, right? So because the patterns don't solve the same problem, we cannot fit everything into the same thing. And that is where the challenge really is. Because if we try to fit everything into the same thing, we might actually use a pattern for the wrong purpose. And that is one of the challenges with this is we cannot just fit them all into one thing because these are solutions. You know, it's kind of like saying, here's a toothpick and here's a screwdriver. Can you show me an example where we can use both a toothpick and a screwdriver? That's going to be a dangerous example that ends up in a dentist office, right? So the point really is we cannot use them for the same purpose. They're pretty, different from each other. How relevant are the Gang of Four design patterns in today's age of microservice and cloud native? They are timeless. Please share your suggestion as how to use the patterns in situations. Absolutely. Well, again, keep in mind, these are tactical. Microservices and cloud native are strategic. You are at a 30,000 feet level with microservices and cloud native applications, but you're still writing your Java code. You're still writing your classes. Design patterns are at the class level and the function level. They are tactical. So think of this as city planning versus street planning. Design patterns are street planning. Microservices are city planning. So the difference is in levels, if you will. To go back to your question, Sivaraj, is these are very relevant today. But of course, how you implement them may change. I might use, so to your question, it's not the microservice or cloud native that affects these patterns. What affects these patterns is lambdas versus classes versus functions. That's what affects your patterns, not your architecture. your architecture doesn't affect your pattern, your implementation does. That's basically what the concern here is. Felix is asking, you don't have to say sir. I really dislike formalities. You just call me Venkat, that's fine. Please take care of your voice. Speaking 90, oh, I speak for 10 hours, but thanks for your concern, appreciate it. So the point really is that we need to really focus on the class level details when it comes to design, versus architecture is really a very high level detail. So these are really relevant. But the difference really good question, by the way, Sivraj, is that the implementation changes the pattern, whether you use design patterns with lambdas or functions, whether you use a functional programming language versus a procedural programming language versus an object-oriented programming language. It makes a difference as to which pattern we may use, not the system level architecture. So when it comes to adapter, the idea behind adapter really is that the adapter gives us the ability for us to sort of use the word adapt or be able to use one interface in another setting. So for example, let's say you have an application where you have a particular, calculator of some sort. So you might say, you may have an interface, let's say in this case as a computer or a calculator, let's say calculator, and the calculator is saying, convert, and it's going to say input in inches, right? So it says input in inches, and it's going to perform some computation and return it. I live in the US and we're still so backward. We still use imperial units, whereas the rest of the world is using metric unit. And we are adamant. We will only use miles, we'll only use feet, we'll only use, all these pounds. We refuse to change. But I think the worst country in the world is UK, because they use kilograms and miles. This completely confuses, making me crazy, right? So I don't know why. But the rest of the civilized world use metric unit. But here is a function called calculator that converts from input inches to whatever the value is. Similarly, it has a function, another convert to, let's say. And what does this convert to do? It takes, let's say in this case, pounds, input in, let's say, pounds, if you will. So when you have these things in different units, how do I use this in another piece of code? So I might have a piece of code where the data in, let's say, meters, if you will, or centimeters is probably more appropriate. So centimeters, and I may also have a data, let's say, that's coming in and data in, let's say, kilograms. So I want to be able to use these consistently in my code. How am I going to be able to do this? So here's an idea. I might say, adapter. So I could say metric to imperial, let's say adapter, and I might then say new calculator and send it, where the calculator may be a class instead of being an interface, if you will. So what is this new metric? So metric to imperial adapter, what does that do? So now I will simply go ahead and call the functions on it. We'll call it as calc right here is equal to. Now I can simply say over here a calc dot, and I may call the function convert on this and send the data in meters. But what does this metric to imperial adapter do? It will take my data, convert from metric to imperial, and then pass it to the calculator. So the one that does the real work is the calculator itself. However, the metric to imperial adapter will take the data, perform the conversion, send it, take the response, perform the conversion in reverse, and send it. So essentially, this is going to be performing the work for us. And maybe rather than convert, a process may be a better, or compute may be a better word here to avoid confusion. So we'll call this as compute, and let's call this as compute 2 as well. So in this case, I'm calling the compute function, but the compute will perform the transformation of the data and send them back and forth, if you will. Now, here's a really silly example of this. I travel international. I'm in different parts of the world every week when I travel. So what do? I go to the Switzerland, and they use an adapter which looks very different in terms of the plug points. Then I go to places like Belgium. They have a little well, and you insert that into it. Then you go to the US, we have a little prong, which is a flat little thing we insert. You go to places like India, you have a circular button and you put that in there. So, but how do I use my computer with all these things? Well, I have a little fancy adapter, a universal adapter. And when I go to a country, I just flip a switch and it gives me the probes for that country, and I can still plug on my site and connect to the power supply. That's basically what an adapter is. The adapters may also perform other kind of transformations too. So if you notice over here, what do we do in here? You have a client one, and the client one is directly using a calculator. But I have a client two, but the client two cannot use the calculator because it really wants to use a metric unit client, right? So it's going to use a metric unit client. That's what the client really is. So what do I do with this? With this client, a metric unit client. Oh, we'll call it as metric unit client. That becomes easier. So this metric unit client talks to a metric to imperial adapter, which then talks to a calculator after that. So that becomes a adapter pattern. So when do you use an adapter pattern? You use an adapter pattern when your client finds a service that it wants to use, but the interfaces don't align. So you put an adapter in between so the request can go through and use the interface that is provided for you. So adapters transform the interface from one interface to another. Now, there are two kinds of adapters available, which is what makes it really fun. One is a class-based adapter, and the other is an object-based adapter. So these two are the two types of adapters that really are available, a class-based adapter and an object-based adapter. A class-based adapter predominantly uses inheritance as a way to adapt. An object-based adapter uses delegation as a way to adapt. What I showed you in this example is an object-based adapter. Notice my metric to imperial adapter is using the calculator. One other way you could do this is you can say class metric to imperial adapter 2 extends, if you will, from the calculator. So this is another way where you'll say super and pass the data to the base class. So this becomes a class-based adapter, whereas what I showed you here is an object-based adapter. So basically in this, thank you. So basically what you're doing here is a class metric-based adapter, if you will, simply says a calculator is equal to, in this case, equal to a new calculator, or, you could say, or, inject this, right? So inject it using a constructor or inject it using a setter, if you will. Then the methods over here will simply say calculator dot and call the function, if you will. So notice super dot function here on the other hand, whereas this calculator dot function over there. So that's the difference between a class-based. So clearly, this is the class-based, right? And this is the object-based, if you will. Now here comes the charm. The class-based adapters versus object-based adapter. Class-based adapters are very limiting. You don't see them too often. And there are limitations to this. Why? Because if you notice, a class-based adapter only adapts calculator because you are inheriting from it. An object-based adapter can adapt not only the calculator, but if you inject it into the constructor or the setter, what you inject may not be a calculator, it may be a derived class of the calculator. So as a result, this is more extensible compared to this one. So class-based adapters are more popular than object-based adapters in general. So that is something to really keep in mind in terms of how these actually can interplay and work. Well, I'll quickly mention about proxy here. Proxy is not one pattern, it's a family of patterns. So what is a proxy in reality? So a proxy stands in for a real object. Now we do this in our real lives, isn't it? We have a stock market and your company, you may be on a board, but you may have a proxy to sign on your behalf. So a proxy is a placeholder, something that stands in for another object. But I said proxies are a family of patterns. How so? Well, you may have what is called a control proxy. So what is a control proxy? You have an object. I put a proxy in front of it, and you make an access to the proxy, and the proxy says, yep, you can have access to, or no, you cannot have access to, and may deny access to you. So a control proxy limits access to the real object, right? That's basically what a control proxy really does for you. On the other hand, you may have a remote proxy. So what does a remote proxy do? Remote proxy makes a remote procedure calls to a remote object. So they will take care of serialization, right? So serialize, and deserialize, and all those operations are done by the proxy. So your code simply says, make a call like it's local, and it makes the call to the remote proxy. It's kind of like a phone, right? I speak in my phone. You could be anywhere in the world, and you and I could be talking to each other. That's a proxy to be able to communicate with somebody remotely. You can also have other kinds of proxies too. For example, in the case of language like C++, you can say a smart pointer. Pointers are really proxies too. Because what do smart pointers do? They take care of reference counting, if you will, and they release objects when they're not needed. So that could be another example of a proxy. So a proxy, again, notice the structure. Here's a client. And what does the client do? The client is talking to a proxy, which in turn is talking to the real object that is behind the scene. So as a result, that's a structural pattern. So the structural pattern, because again, we are talking about how the objects are arranged or structured for us to be able to provide this kind of service. That's basically a structural pattern that you are seeing in here. So thanks. So that's basically the idea, is how you structure these so that you're able to achieve your goal. And the purpose of a proxy pattern is you want the client to be able to talk to a real object, but you want to add some kind of convenience. Convenience to limit access, maybe. Convenience to do remote procedure calls, maybe. Convenience to garbage collect the object, maybe, and so on. So your goal is to make your life easier to talk to an object. That's where the proxy patterns really come in. Well, we got about 20 more minutes with us. It's a really good time for us to talk about the next one here. And I want to talk about two different patterns in this area. But this is a behavioral pattern. So what's a behavioral pattern? A behavioral pattern is algorithm, or how do you work with an object to achieve some task. Let me give you an example of this, which is going to illustrate the problem really well. So let's say we have an array list, and I'm going to say this is integer, and I'll say numbers, let's say, is equal to, and I'm going to say new array, well, let's say arrays dot as list. And let's go ahead and say this is going to be 1, 2, 3, 4, 5, and 6. Well, now I want to say, process. And the process function is going to take numbers and do the processing. Now, what I'm going to do here is I'm going to say a public static void process. And this is going to take an array list of integer numbers. And what I'm going to do in here is simply say, I'm going to write a code in a boring way just to illustrate the point. So I'm going to say in here, a var iterator is equal to numbers dot iterator. Then I say while iterator dot has next, and I'm going to simply say output iterator dot next. Now you may look at this and say, oh, Venkat, why don't you simply go ahead and call the function for loop? Yeah, I could, but I just wanted to illustrate the point in here to see what that really means to us in this context. Let's look at the error and fix it. So it's not happy on line number 13. So what did I do in line 13? Oh, arrays. Okay, so I was trying to really avoid that, but let's go ahead and take the harder route. So here is the object I'm creating of the array list, and I'm going to send that over. So let's go ahead and try this one more time. I'm going to make the font a little bigger in just a second. So there is my array list that we created, and we are going to iterate through it. Now, when you look at this code, what is the problem with this code? The problem with this code is, process is a very poorly designed method from the point of view of extensibility. So if I were to come to you and ask the question, thank you. So if I were to come to you and ask the question about this function and say, what do you think of this? As a programmer, you need to be able to tell me, oh, Venkat, please don't do this. This is bad. Why is it bad? The reason it's bad is, from the software design point of view, process is tightly coupled to array list. Now, this is really terrible design because we all know tight coupling is really bad, and it fails the open-closed principle. So how does it fail the open-closed principle? The reason it fails the open-closed principle is tomorrow I decide to do the following. I say set of integer over here, and I say numbers 2, is equal to set of, let's say again, 1, 2, 3, 4, 5, 6 again. But this time I call process function and I send the numbers 2. Notice the code will not compile. The code fails compilation. But why? The reason is this is saying, give me an array list, whereas I have a set, I cannot use process. So as a result, the problem is, so somebody is saying the screen is too small right now. So if there is a way for one of the organizers to please take a look and make the screen bigger so they focus more on the code than on anything else, that would be really useful. So thanks for that feedback. Thank you. Yeah, screen is too small. Okay, so if anybody can fix that, that'll be great. I don't have control over it right now, how to do it. But if one of you can take care of that, or maybe there's a setting on your side where you can make the screen bigger. So thank you. So the process function is terrible because it's tightly coupled, as you can see here, and that makes it really hard for us to work with it. So what am I going to do instead? Well, what I'm going to do instead is I am going to go over to this function and say numbers.iterator. And similarly, numbers2.iterator. So notice I'm calling the iterator function on both of those right there. However, what does the process function then do? The process function says, I am not going to take an array list. I'm not even going to take a list. I'm going to simply take an iterator right there. So now, when we go back and run the code, look at the beauty of this approach. So when I output this code and run this code, when you look at the output, notice that in this case, so while the iterator has next, so where is the iterator? Of course, this is iterator, but let's call this numbers. How about that? So numbers has next, give me the next number. So when I run the code this time, notice it gives us the same output for both of those. But I was able to, so again, people are requesting, so you can pin his screen. So Govind is saying that you can pin the screen. So maybe you want to try that and pin the screen so it becomes a lot bigger. Okay, so essentially in this case, you can see how I decoupled. How did I decouple? So process now, which failed open closed principle a few minutes ago, now is a lot better and is using the dependency, dependency inversion principle. So what I'm alluding to right here is that when it comes to design patterns, we're using the iterator pattern here. But the iterator pattern actually uses a principle called the dependency inversion principle. So the dependency inversion principle says that a function or a class must not depend on a concrete class like an array list. Instead, it should depend on an abstraction where the concrete class also depends on that abstraction. So if you are curious about it, you can come down here and say numbers, and you can print the entire numbers. But watch carefully at the output. The output on the top shows array list $iter. The one in the bottom says collection $set n iterator. So notice both of them give you iterators, but the iterators are different iterators. But the moral of the story is you have a client. The client wants to iterate over different collections, right? That's what you want to do. So originally, your client was talking to a array list, and this is called a bad idea. So now you're saying my client, on the other hand, is going to talk to an iterator, if you will. So what is the iterator? Well, your array list is going to provide you an iterator. So here is a array list iterator, which implements the iterator. You also have a set iterator, right? So you have a set iterator, and you also have, if you really wanted to, you can have a linked list iterator, right? So linked list iterator. And here comes the charm. I've got a client in India, and I come down to visit them quite often. And what they have done is they have their own domain-specific classes. So domain-specific collection, so specific collection. And guess what they did? They created their own iterator for their domain-specific collection iterator. And by doing so, they have the same iteration that they can use. And as a result, it becomes really easy for them to use these iterations. So in other words, the iterator pattern creates an abstraction, and your client can use the iterator to iterate. To get full screen, go to the 3 dots icon, close to the present now icon, and then choose the full screen. You can look at your chat for more instructions how to do it, but if you want a full screen, go to the 3 dot icon next to the present now and change it to full screen. Thanks for that. Appreciate that feedback. So essentially here, the iterator gives a way for you to iterate, and it makes the client code extensible. It decouples. It honors the open close principle. It uses the dependency inversion principle, and you can have different implementations, but it can uniformly iterate over them. Your algorithm here is iteration. That's what you're doing with the iterator pattern. Likewise, a strategy is where you might want to change how you do certain things. I'll give you an example of strategy. I worked for a client once where we did a lot of math calculations. So math calculations, calculations. So these math calculations were really related to chemical engineering. We will do material studies. We would take densities and pressure and component properties and run through literally millions of calculations. So our algorithm would really do the calculation. So we had several algorithms that we would use. But there was one problem. A chemical engineer would sit down and they will have the application in front of them, and they would say, run simulation. And boom, it runs through and produces the result. But here comes the problem. There are times when the engineer is trying to really adjust the engineerings so that they can get close to what they want to get. Right then, accuracy is not important. Speed is important. So sometimes you want speed. Then once they get something very close to what they want, then they would want more accuracy. So when the accuracy is important, they don't mind spending more time, but they want this to be really, really accurate. Well, you cannot have both because computations are expensive. And so what they would literally do is in the application, at the very top, they would have a little, drop down, and they would click on the drop down and they would select speed, or they would click on the drop down and select accuracy. And based on what they select, we will switch the strategy that we are using. So it may be in a speed strategy or an accuracy strategy. How do we actually do that? So I'll give you an example of how we can accomplish it with a little example here. But in this case, instead of using a class, I'm going to use lambdas to show this. Suppose we have a list of numbers, we'll call it numbers, is equal to, let's say, list of numbers 1 to 10. What I want to do in here is, in this case, I want to say total values. So if I say total values, let's say total values numbers. Now, how am I going to implement the total values? I could say public static, let's say int, and total values takes a list of integer, let's call it as integer numbers. And in this example, I'm going to say var result is equal to 0, and I'm going to return the result in the very end right there. But I'm going to say a var int element coming from numbers. I want to simply total result, let's say, plus equal to the element. Well, let's start with this little example and see where we are going. Suppose we wrote the code like this, and you can see that it's going to produce the total of those values, which is 55. But let's say a few days goes by, we now want total of even numbers. Now, how do I find the total of even numbers? I can go back here and say total of even numbers. And then, what do I do for even numbers? I'm going to copy this and paste it. And this time, I'll say even numbers. And I'll say if the element mod 2 is equal to 0, then do the total, not otherwise. Now, if I do this, the code works. But what is the problem? We copied and pasted the code. Now, we all can agree, copying and pasting code is evil. Would you have lunch with somebody who does copy and paste for a living? You're going to stay away. You're going to practice social distancing from them forever, right? Not just during the pandemic. Because who wants to sit and eat food with somebody who does copy and pasting, isn't it? So this is not going to get us friends. So what can we do? Let's apply the strategy. But what's the strategy? The strategy is you want to total the values. That's your algorithm. But the strategy is all the values are only the even values, or only the odd values, or only numbers greater than some number. Those are your strategy. So notice what I'm going to do now. I'm going to remove that part, and I'm going to come down here. We'll come back to this in a few minutes. And I'm going to say, comma, given an element, return true. I want to process all the elements. Then I go up here, and I import java.util.function.predicate. And then I say right here, comma, a predicate of integer, and I'm going to say selector. Then I come down here and say if selector.test of the element is true, then perform the calculation, otherwise don't. Now notice this computed the total of all the values. But here comes the charm. I'm going to go ahead and write this one more time and one more time. But here is E mod 2 is equal to 0. And here is E mod 2 is not equal to 0. And when I run the code, you can see that's total of all the numbers, total of only numbers that are even, total of numbers that are only odd. And if you really like to, total values, again, numbers, comma, E, where E is greater than 5. And that's going to be total of only numbers that are greater than 5 and not other numbers. So when I run the code, you can see that's the output that we are seeing right there. Oops, let me try this again. So that's the output we are seeing right there in the output. It doesn't want to stay up for some reason. So that's basically the output we are seeing. So what did we do in this particular example? So what we did in this particular example is this is the strategy that we are sending to that function total values. So the strategy pattern is you can vary the algorithm's behavior by varying the strategy alone. And this gives you a nice flexibility for you to keep your algorithm the same, but vary the strategy. I'll give you one more example to illustrate this. Suppose you have a search and you want to process all employees who meet criteria, right? That's your algorithm. But the question is, how do you search for them? Well, you may have a strategy. So one strategy may be a binary search, right? Another strategy may be, whatever that you want to use. So you can say, here's one strategy as how to really search, and here is another strategy, and maybe a third strategy, if you will, and you can vary all these strategies the way you want to, and that gives you the ability to decide, while keeping the algorithm the same, you can vary minor details about it. And that is where the strategy pattern really comes in. So strategy is, again, a behavioral pattern because you're focused on an algorithm, but you vary parts of it, and that becomes really powerful. So to summarize what we talked about what design patterns are. We first talked about why these are not the best thing to invest in the beginning. It takes a lot of time and effort and experience to get really good at finding the patterns. So one of the best ways to find patterns is to get feedback. Work with somebody, do something, get it reviewed, rewrite it, and over time, you get better at identifying patterns. In the beginning, we're going to really be bad with it, but with experience, we get better with it. And patterns really are helpful because we can reuse ideas that have been used over and over and over again, so we can gain from collective wisdom and collective experience. The patterns are useful to solve a particular type of problems, generally abstracting, creating objects, or how we structure objects, or how we communicate to implement our algorithms, and so on. So that's all I'm going to talk about. I am very interested in hearing your thoughts. If you have any questions or comments, please post them on the chat. I'll be delighted to answer your questions. I also see Morgan has posted the link for the feedback. So if you would please take the time to provide the feedback, that'll be really helpful. That will also help him to decide if I should be kicked out, or maybe I could be invited again to talk again to this group. I'll be more than happy if that's a possibility. So I'll stay around for questions, comments, and thoughts. So it's your turn to speak or to type. You can type, or you can open your microphone and speak as well. Your choice. So one of the questions is, are there overheads in using design patterns? Really good question. And the answer is absolutely yes, because we may end up using a wrong pattern. That's one of the overhead. You might use a pattern for the sake of using a pattern, and that might introduce an unnecessary structure into the code, which was not needed. So if a pattern is misused, it often ends up with the overhead. But if you don't use a pattern incorrectly, if you're using a pattern for the right reason, then I wouldn't call it as an overhead, because without using that particular pattern, you may be able to solve a pattern differently, but that may have other consequences. So the overhead is a little tricky in those situations. Any code you write is an overhead, right? Because the code you don't write is the one that doesn't take any overhead at all. So the minute we start writing code, we have overhead. But when misused, it's overhead. When used for the right reason, it is not overhead. It is essential to solve the problem. So, but to your point, one of the most problematic overhead is misusing them. One of the other question is, are the patterns limited to 23 classic ones, or any new patterns are developed? Well, there's a lot of different patterns being developed constantly. One example is one of my favorite patterns, which is not covered in the 23 in the book, which is the execute around method pattern. Execute around method pattern is a pattern where we can use lambdas to provide a nice behavior. Another pattern is called the composite pattern. Not the composite pattern, the cascade pattern, where it's like the builder pattern, which is not talked in 23. So that's just two examples, right? But there are so many examples you can look at. So there are patterns constantly being discovered. And so definitely they're not limited to the 23. Other questions or comments? Can we reduce the technical debt using design patterns? I don't think so personally, because technical debts are too broad and patterns may not be the right solution. In fact, to your point, I might say one of the technical debt may be the wrong use of patterns. Any optimization technique which could be used here? None that I know of, because optimization is too broad a topic to apply in this context. So unless there are specifics, I don't know of any optimization techniques we could actually use. Other thoughts, other questions? Anyone can ask question. I only see a few people ask questions. What about other people? What is on your mind? What is the precise name for the book? Design patterns. Usually if you Google for Gang of Four, you'll be able to find it, but let me Google for it. So this is the world famous design patterns book. So design patterns book, that's all I'm Googling for. And the first one that comes with that Googling is the name of the book. So Google for design patterns book. That's all I did. Right there is the first one you see right there is the book, right? So design patterns, elements of reusable object-oriented software. So that's the book. So right there is the title on the right side. So do the Agile developers use design patterns? I hope not. They should be solving real problems, not use design patterns. So Agile developers should be solving problems for customers, not spend their days using design patterns. If patterns are useful in the process, that's well and good, but that shouldn't be the mission of the Agile developers. Thank you. Yeah. Other questions, other thoughts? Don't be shy, don't be shy. I don't know a lot of stuff. I'm still learning. So it's good to also learn from other people. So ask your questions. Is testing simpler when design patterns are used? No, they're not any simpler or they're not any harder. Design patterns themselves don't influence testing. Somebody ask a question before Mohan asks another question. Thank you. It's good to get so many questions, so I'm really appreciative of that. But I want others to ask questions too. So don't be shy. All right, I'm not seeing many other questions. Selection of design pattern is a trial and error process. It's more of a heuristics. It is more than a trial and error. Well, it's a trial and error, but rather than the error is a negative connotation, it's a heuristics. It comes from experience. It is subjective, and there's no one right answer. So it is something we develop with practice over time. And it's really hard to use a pattern. I'll give you an example to answer your question, Mohan. I had a developer come to my office and said, hey, I'm using this pattern. I'm having trouble with it. Can you help me? And I said, yep, let's talk about it. And he said, let me talk about the patterns. No, talk about the problem. And he talks about the problem. And I said, oh, that's an interesting problem. Can we solve it like this? And so we are drawing a little diagram. And then a few minutes later, he's like, yeah, that'll work. And then he said, what's the pattern called? And I said, the name of the pattern. He said, interesting. That's a very easy solution. I can implement it in 10 minutes. And then as he was leaving, he said, wait, but I came to you to ask if I can use the pattern. Do you think I can use it? And I said, well, what's your goal? Is your goal to solve the problem? Or is your goal to use that specific pattern? He smiled and walked away. So the point really is, it takes a lot of experience. I'm not saying by any stretch of imagination that I'm good at it. All I keep saying is it takes experience, and I don't have that much. I need to still gain, like a lot of other people do. But it really comes with experience. So a lot of times what I do is I go to other people and say, hey, does this make sense? Should we use this? Are there other alternatives? So it comes from discussions. It comes from heuristics. It comes from debating. It comes from prototyping. To go back to your point, more than trial and error, it comes from prototyping. So when people say, can I use it? I say, write a prototype, mock it up, try it out, and see how it goes. If it works really well, got it. If it doesn't, throw it away, do something else. So it comes from experience and experimentation more than anything else. Well, I really want to thank you for attending. Thanks so much. I appreciate it.
Yeah, one more last question.
Yeah,
one more last question.
Please.
What percentage of people use design pattern in development?
Oh, I would say, unfortunately, most of them do. And I say unfortunate because a lot of them misuse it. So design patterns are often misused than being used properly. That's why this is think of this as a chainsaw. You want to give a chainsaw to a child, it's dangerous. You want to give a chainsaw to a person who doesn't know what to do with it, it's dangerous. So design patterns are chainsaws in that regard. So they're often misused than being used, unfortunately. So that's why I always criticize using patterns. If you go to Twitter and search for it, you'll find a tweet I posted maybe 2 or 3 years ago. On my tweet simply said, nobody retires, saying, I wish I had used more design pattern. And I really wanted to emphasize that in the tweet because people are, going really overboard with using design patterns. So the goal should not be to use a design pattern. The goal should be to solve a problem in a way it's maintainable and provides value for the customers. So more people than they should actually use the pattern. So we should definitely be careful about it.
So does it mean that people need to have some experience in using design patterns?
I would say they need experience for anything in life. But the problem in our industry is we go from school to thinking we are experienced. We close a lot. That is one of the biggest problems. To be a really good software developer, we need to have a very open mind. We must be willing to be criticized. We must be willing to take criticism. Oh gosh, I'm throwing a blank right now. Newton said, I see farthest because I stand on the shoulders of giants. That's what he said. I cannot emphasize that statement. We are not Newton, but if that's what Newton had to say, you can only imagine for people like me who are mortals. The point really is, I know quite a bit, not because I'm smart. I know quite a bit because I open myself for criticism. So go to a colleague and say, hey, I'm doing this. Can this be better? And have that critiqued, have that code reviewed. The more we review in our industry, some of the colleagues I work with, some of the students I work with, some of the faculty I work with, some of the people I work with in industry, we are striving to become better by critiquing each other. It is not about personal, it's not about ego, it's not about insult. It is about professionalism. It's about saying, hey, here's what I wrote. Can I make this better? Tell me your ideas. It doesn't mean you are right. It doesn't mean I'm wrong. It means we both can learn and become better. So it's not just for design patterns alone. In our entire field of software development, we need a lot more collaboration. We need a lot more of this critiquing that we need to do. And that's the only way we can get better, actually.
What type of training would you recommend for the freshers to get into design patterns?
It's not a training, it's a mentorship. So find a mentor, find somebody who is genuinely interested in learning with you and learn with them, right? So it may be a colleague, it may be a fellow student, it may be an instructor who is really keen on learning, and have them code review your code every single day and change it and evolve it. I teach remotely at the University of Houston. And one of the things I've done over the past about several years is I quit teaching. I put my recordings on the web and say, go listen to it. But let's do code reviews. So my students write code every single day. And every day I spend 3 hours reading every line of code that they write, critique it, and then send them a feedback and say, here you go. Now make a change based on what you have learned from this. And they make the change to the code and they come back the next day and then the next day and the next day. And they learn by writing code every single day. So it's not a training program, it's a mentorship. So you learn by doing. How does somebody learn music? How does somebody learn to play piano? They don't learn piano by listening to somebody play piano, even though that's important. You learn piano by making really lot of ugly noise. It's horrible to hear. And then somebody patiently puts on headphones and listens to you and says, yeah, let's try this again. Let's try this again. Let's try this again. And then one day we become a lot better playing it. Music playing is exactly learned by creating a lot of bad music and have somebody review it and help us. Software development is exactly that as well. We fail to recognize that quite often, unfortunately.
And you are mentioning design pattern is more of a prototyping exercise. How do the developers factor the time during the project development?
Yeah. So think of the time for a minute, right? Time is such a beautiful thing. Imagine you know how to ride a bicycle, and imagine you have never ever driven a car. And I tell you, if you have a car, you can get to the place where you want to get to in 10 minutes and not take 2 hours to get there. Well, you say, wait a minute, it's going to take me time because I don't know driving. I need to spend the time learning to drive. That's going to take a few months. But we all did. And once we did, we're so good at driving, we get there really fast. So the point really is when we develop the right kind of skills, we lower the time in the long run. When we defer developing the right kind of skills, we lengthen the time in the long run. So that is the trickery about the time. If I am low skilled, I'm going to take more time forever. If I spend the time to become skilled, I reduce the time in the long run. And that is something we fail to recognize in professional development, even though we are following that in other things like taking the time to drive a car. So ask the question, without the skill, how much time does it take? With the skill, how much time does it take? And what is the time it takes to get that skill? That is a better question to ask and answer, I think.
Actually, if the system has been developed using design pattern principles, the maintenance becomes much simpler. So, which means that
I disagree. It might be actually terrible to maintain because they use the wrong patterns in the place. So I don't think I can make that claim, unfortunately.
Okay, then who decides whether the pattern used is right or wrong?
The team has to. That's why if a sole developer goes out and creates a mess, then everybody else has to deal with it in the long run. This is why collaboration is so important. Code reviews are so important. This is why discipline is important. This is why professionalism is important. I cannot, how many times we see developers write really terrible, poor quality code and walk away, and then we suffer the consequence of it. Instead, if we say, wait, let's actually bring some discipline into development. Let's actually take the time to review what we do. Let's make sure that we do code reviews and design reviews. Well, yes, those things take time, but in the long run, they reduce the time and the risk of development. This is what, I would say mature organizations and teams do. The immature ones suffer the consequence. The mature ones invest the time so they can gain the time in the long run.
Do the end user have any say in insisting using design patterns in development?
I hope not. They should never know whether using a pattern or not. It is not their concern at all. Their concern is, have you given a product that is useful for them? That's what they need to really worry about.
No, in fact, that is the problem, that many of the products are developed trying to provide the solution as the end user wants it, without really going into the design principles. So, how to optimize that issue?
Well, this is where the development aspect comes in, right? So think of a professional like a doctor. If a doctor is going to serve a patient, a doctor still has to use certain practices so the patient doesn't have consequences in the long run. The goal is not to take the bullet out. The goal is to make the patient survive after taking the bullet out. So this is the 1820s, right? In the 1820s, patients went for surgery and a lot of them died after that. And the reason is the doctors never followed good practices. They were carrying germs with them. So essentially the patients left the hospital. Yay, I did my surgery. I'm alive, only to die in the next 3 to 4 weeks. Now, the doctors take the time to wash their hands with soap constantly. They sterilize their equipment. They keep their environment really safe. That's cost, right? But why do they do it? Because the patients survive after surgery, or at least the risk of them dying is much less. That's professionalism. We need to bring that into our field. We cannot simply say, throw something out to the customers because that's what they want. Well, the two things, right? They must be able to use the product we develop. Second, software development is much like in the medical field. They survive the surgery, but they die in 3 weeks. That's no point. Similarly, in our field, you develop a software and deliver to them, they come back with changes 2 months from now. If it's going to take a lot of time and effort and cost to make the change, then we're not going to be able to sustain the pace of development. So the discipline is really important for us to be able to sustain. We need to have a holistic view of that. There are things we do that directly impacts the users. There are things that we do that has consequences to what we do for the users eventually, but that becomes a technical discipline and practices for us to attain that kind of delivery. And if we don't do that, that's like doctors who touch everybody, don't wash their hands, and you're like, gosh, what are you doing? And they're like, what's happening? And I, honestly, right, I'll share with you a story that just bothers me absolutely. My son was not feeling well. I took him to the doctor, and the doctor diagnoses him and says, well, okay, so here's what we're going to do. You're going to buy this package, you're going to use this medicine, and 3 weeks later, we'll check how he's doing. I said, you know what, that's great. Thanks for sharing that. Thanks for making me buy that. I don't have a problem paying and buying it, but can you tell me how this actually helped my son with the situation now? And the doctor literally looked at me and said, so now you're the doctor, huh? And I said, I'm not the doctor, but you lost my respect in the process because you no longer are the doctor that I trust. We are done, and I'm leaving. And I literally left the hospital, took him right across the street to another hospital. And the doctor there looked at him and said, oh my gosh, this guy has pneumonia. He cannot go to school anymore. Here's the medicine you have to take, and come back tomorrow, we'll check him again. And this is the problem, right? These two are doctors. One was professional and the other one was not. Well, if this is what happens in the medical industry, what can we say about software field, right? So not everybody in the field is the same. And the question we have to ask is not about who they are, but who we want to be. Do I want to be the doctor who tried to sell things that I didn't need? Or do I want to be the doctor who saved my son's life? So do I want to do what's right? Or do I want to be part of that malpractice? That's a question that every one of us has to ask and decide for ourselves.
Okay, the last one. Could you briefly tell us about some of the books you have written? Because we find lots of books, very interesting books. We have seen the list of books, you have contributed. Can you just briefly?
I don't talk much about what I do, but I'll quickly show here. I don't know if you're able to see my screen still, but on my screen, yes. I have the list of books. So my most recent book was on Kotlin DSL. And before that, I wrote a book on Kotlin, book on rediscovering JavaScript, one on test driving JavaScript applications, and so on. So I think I've written about 12 books so far, if I'm not mistaken. But if you're curious about it, I would say go to agiledeveloper.com. That's my website, and you should be able to see the list of books over there. Or just Google for my name, and you'll find my link.
Thank you, Mr. Venkat, for the excellent presentation. And we really enjoyed because it has given right from beginning the fundamentals of design patterns. And we really thank you for your time and efforts. May I request Dr. Saktivel to formally propose the vote of thanks. Saktivel.
Good evening, sir. On behalf of the Computer Society of India Chennai chapter, ACM Chennai professional chapters, and the IEEE Computer Society Madras chapter, we would like to thank Dr. Venkat Subramaniam, today's resource person, who has delivered a wonderful lecture on design patterns, a quick introduction. Thank you very much, sir. On behalf of all the societies, we would like to thank all the participants who have attended this webinar. Thank you, all the participants. And I would like to thank Mr. H.R. Mohan, Chairman, ACM Chennai Chapter, Mr. P.V. Subramanian, Chairman, CSI Chennai Chapter, and Mr. Dr. Aguila, CSI Chennai Chapter, for their support in organizing this webinar. Thank you, Anandal. Thank you.
Thank you. Thank you very much for everyone.
Excellent.
Thank you.
I think we woke you up in the morning.
Oh, no problem at all. I'm usually up pretty early. Thank you.
It is an excellent overview. This though we have been reading something about design patterns, but the presentation has been so mind-boggling and very wonderful.
Thank you. I'm glad it was useful. Anytime, let me know. I'll be more than happy to come and speak. We can also do Q&A sessions if that's useful. I'll be more than happy rather than a presentation. If people want to just ask questions and answer, talk about career, talk about programming, just about anything, I'll be more than happy to be part of it.
In fact, I had gone through some of your presentations, the list of presentations and talks you have given, and we have identified at least half a dozen, which will have a real impact on our people. Basically, the members, they will definitely learn. Of course, they're all nothing directly to do with any of the programming language and things like that. It's the generic talks. So that basically the people lack what you said, the discipline is the one which is not there. They are good at trying to learn the coding, but how effectively use and what are the development methodologies they need to apply, and how to study the problem as such, it is not known to them. So they simply think that writing code is the end of it. So in fact, these practices of agile development working in the real world, I think that book you have written. So that also, that type of books, not many books are available. So many of them, either they talk only about the coding or something, some functions of the features of a particular language, and some examples, which may not be directly having relevance to the real world problems. So connecting the real world problem and development, so very few books we have seen. So I think this might be one such. Maybe sometime later, after giving about some 3 to 4 months time for you, we would like to disturb you once again.
It's not a disturbance at all. I'll be very happy anytime. Let me know. It'll be my pleasure.
So we'd like to have another talk. So we'll come back to you. By maybe with the first quarter of 2021.
Sounds good.
That should be fine.
Wonderful.
Okay.
Thanks to everyone. Thanks for everyone joining.
Thank you.
Appreciate it. Thank you.
Thank you, Dr. Venkat. Thank you.
Thank you.